Good evening, everyone. This is Sandeep Giri. I'll be the instructor for today for the Big Data and Hadoop session. And you can communicate to me immediately using Q&A. And before proceeding further, I would like to, have a introduction with all of you, a basic, where are you located and on what kind of technologies you are working on, and what do you look forward to in these sessions. Are you able to hear me clearly? Hi. So, so before starting, I would like to have a brief introduction about all of you. Okay. So today we are lucky that we are only having close to 25 attendees, and on Wednesday we had close to 90 attendees. So it became difficult for the introduction, and therefore we have limited number of people. So before moving forward, I would like to have an introduction of all of you for next 10 minutes, and then we will move forward. Yes, Anima, as a process, uh, everyone except the instructor is muted so that there is no collision. And the way you have to communicate with the instructor is by typing in the questions box. That gives me an ample amount of time and ability to answer your questions individually. Okay. Otherwise, it will not be possible to communicate. So that is the general modus operandi of these sessions, where all of us, all of the attendees are muted except for the instructor. Okay. So Vishnath is asking that will the recorded sessions will be available? Yes, all the sessions will be available. And okay. So Sanjeevan is a 5 years experience Java developer from Bangalore. Great, great. Okay. Giriraj is working with Copula Technologies. Excellent. And Arvind is running a startup called Melees, and they are working on a team email solutions. Vivek Kuneja is a cloud architect from Korea. Excellent. Nice to have Vivek in the sessions, and we would love to have your feedback on our sessions as well. And yes, Akhilesh, you will have to introduce yourself by typing into the questions box. Okay, you're right. And Arvind is a Python developer for 3 years, based in Chennai, India. Great, Arvind. Kavita is from SAP Labs. Excellent. Akshay Joshi is from Bangalore. Excellent. Okay, so Urja is a junior year computer science student in Bangalore. And Deepesh is working as a Java developer. Okay, great to know. Prashant is working in various .NET technologies. And okay, Vishnath is a freelance programmer. So we have got a great Alan. Alan is from Chennai, working in an IT organization, multinational, as program manager. And Amit is in a creative health as ETL developer. Excellent, Amit. Okay, and Anant. Okay, hi Senthil. And Senthil is working on resource management on cloud. Excellent. And Akhilesh is a team lead in Accenture Bangalore in Microsoft Technologies. Megha is a final year student. And Karthik is hi Karthik. Karthik is living in US, working in SDE for a startup company. Excellent. And Rakesh Kolipara is an iOS developer working in Hyderabad, but is quite enthusiastic about big data, and he's a starter in this. Okay, great. And his Megha is from computer science background. Okay, Rohit is also third year engineering student. Great, great. And Suman is working on a mainframe technologies, and Ashish is a J2E developer in EMC with 10 plus years of experience. Excellent, Ashish. Welcome to the session, and we would like to have the. Uh, we are actually very glad to have people from various background. We have uh, program managers, we have students, we have SDs, and we have entrepreneurs in the session, and we have experienced ETL developers. So I'm very glad to have such kind of a session. And we have now like 30 members online. So I will not be able to, because I'm having a little bit of throat infection, so I may not be able to uh, y- uh, my- be my usual self. I'll be speaking a little slower today, and I hope that should not be a problem. I had to cancel one of my sessions today morning, but great, great. So here we are. Now let's start with the session. So before going further, let me introduce the company called KnowBigData, which we started in April 1st. And we are basically right now into training on big data and related technologies. Okay, our core focus is only the big data. Okay. We saw a gap in the industry and we thought that we can make a difference. And the sole objective of No Big Data is to build a great network of people who are into big data or who have learned big data and are enthusiastic about big data. So that is the sole objective of No Big Data. And we promote asking a lot of questions, and that is probably one of the reasons we stopped doing physical sessions, because in physical sessions people do not ask many questions. We record the whole video and make it available to all the candidates, and as well as all the question answers, all the slides, everything is lifelong accessible to all the candidates. As an example, today's session is going to get recorded and we will send you the link to the YouTube recording of this session, as well as the PPT presentation of this session I'll be sharing with you. All right. So even though it's a free session, but we make sure that the content should be accessible to the people for lifelong. And same is true for our paid sessions. And other than that, we have okay. So we have got a professor also in VIT University, Vellore. Welcome, Senthil. I'm very happy. Okay. Wow. Okay. And we have got something which other companies are not able to provide, and they I may not know, is a cluster access for the experimentation. So we have built our own cluster which we give to our students for finishing the exercise, doing their own personal experimentation, and at the end of the session, we have a project which is generally in a collaboration with the industry. Okay, with various companies we have got a tie up with. So they give us the project, and we assign that those projects to our candidates who are enthusiastic about it. Or some of the students come up with their own project and then they start working on those. So all of the projects also happen on the same cluster. Okay. So and we give the access to the candidate so that there is no inertia to start with the, say, Piglatin or any of these tools, and instead of getting stuck with system issues that we could not, our machine was not working, our office doesn't allow us installing this or that. So people and so you get a lot of exposure to the whole cluster. How does a cluster functions? So to give that real experience as well as to give a immediate access to these tools, we have set up a cluster, and as soon as candidates sign up with us, we give them the access to the cluster. Okay. And we provide a 24 by 7 support to all the your questions, your you know in case you have a doubt, in case you are stuck somewhere while doing exercise, or when you are accessing the cloud you are not able to access some things. So we provide a 24 by 7 support. Okay. And other than that, we provide a lot of quizzes and certification tests, as which are also very much aligned with other certifications. And this particular course is 10 sessions. Each session is 3 hours. First session, this is the first session, and which is free, and 9 more sessions will be there. And this is a Saturday Sunday course from 8:30 to 11:30. And other than usual certificate and all, we provide you a socio-pro visibility, meaning all the candidates who are passing out from our classes, we generally give them a LinkedIn recommendation. We give them we make their certificate accessible in the World Wide Web. Okay. And also, if some people are inclined for appearing for job and all, we also connect them with the recruiters, and in case they wish, we can help them with the mock interviews. So that's all about No Big Data. And about myself, I'm Sandeep Giri. I did my graduation from IIT Roorkee. I somehow finished my BTech in chemical engineering, but did a lot of programming during college. And then I was hired by D Show. I worked there for 3.5 years, and that is the time actually when we had a 10,000 nodes cluster at that point of time. Okay, which nobody was exposed to at that moment of time in 2002. And we were running a lot of parallel programming tasks which are similar to Apache Spark as you see it right now, which was not similar to what we have like MapReduce. The stuff which we were doing was similar to Apache Spark. So that was my tenure in Deisha. Then I started a company called Tbits Global. We built a enterprise grade document management system, and the company is still running. And then I joined in Mobi, where I built a recommendation after churning 200 terabyte of data. And then I joined Amazon, where I built a very high throughput system for 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 their in-house, on top of their in-house NoSQL. Uh, yeah, we have I mean, the next derivative of Dynamo at Amazon. So I built high throughput system similar to Apache Storm. Okay, for lot of parallelization on individual nodes. And then in 2014 April, I started No Big Data after leaving Amazon. So this is what it is. So Akhilesh is questioning, if I miss a session, can I join another live session on the same topic? Yes, you can join that. So some of the candidates, they drop my classes in earlier, they will be joining this particular batch. They had to, for personal reasons, they had to drop those. They can join. So the relationship which we try to keep is a lifelong, and we do not we it's not about the process and the organization. It's more about having a connection between the candidates and us. So because there are a lot of magical things that can happen. Okay, like for example, one of our candidates who I am working with is based out of New York, and he's actually starting up a company on KnowBigData, and I'll be his advisor on how to deal with that kind of problems, because the project which he was doing, he has taken it up as a full-time one, and he's starting up on that particular project. So there are a lot of magical things that could happen if we have a great this. Are the rest 9 session paid sessions? Yes, Anima. Rest of the 9 sessions are paid sessions, but that does not mean that this session will be incomplete in any manner. This session will be sufficient for those who are looking for introductory classes or the basics, or those who are trying to figure out whether an online session works or not. All right. So Akshay, I will tell you the details about the paid class. All right. No, do not worry about it right now. Okay. Cost and all, I'll tell the details at the end. Okay. So I'm based out of Bangalore right now. Okay. And one of the team who is working is out of New York now. And I mean, we are basically expanding. Okay. Because we do not really need a physical office to work, right? So therefore, the expansion is actually happening pretty fast. All right. Thank you, Akshay. So the course content for today is we'll talk about big data and then Hadoop architecture. Now, in today's class, what and why about big data? Why now? Example customers. What is Hadoop? And then we'll go into Hadoop architecture in detail. All right. So now, so this is a very common and cliche question in today's time. What is big data? So, but I'll still ask you that what does big data mean to you? So, what does big data mean to you? Lots of data. Okay, excellent. And let me just verify if the recording is running. Yeah, recording is running. Okay. So we have 34 candidates right now logged in. Okay. So Rajendran's answer is volume, variety, and velocity. Excellent. That's IBM's definition, and probably you missed a new V they introduced. More than billion records. Okay. Okay. History data. Okay. Managing huge data. Okay. RDBMS not able to process. Excellent point. Excellent point, Amit. And big data is contextual based on the domain. That's also a good point. Processing huge amount of data in microseconds. Interesting. Interesting. Thank you, Rajnikant. And where there's a flight traveling from Bangalore to New York, there's enormous amount of data which is collected, basically complex data. That's a good point, Akshay. Data that cannot be processed with traditional database technologies. Yes, good, good. And probably this is the most closest definition. Huge amount of data, unstructured data. Excellent, excellent. So out of this, out of all of these, because data which is raw and need processing. Thank you, Prashant. Good. To get something out of the raw and raw data and need processing to get something out of it. Excellent, Prashant. Excellent. So, see, what you have just told is some of you has actually told the attribute of the data in general, how do we define. Okay, and most of your definitions are correct in that aspect. So, in very simple words, the data of very big size, and we find difficult to process that data with our usual tools, and therefore a distributed architecture is needed, and this data could be structured or unstructured. So fourth point is actually irrelevant when defining big data, because data is anyway data. It can be structured, unstructured, or whatever, semi structured, or semi unstructured, or whatever we would like to call it. So data is data. So fourth point is irrelevant. In very simple words, data of very big size which you find it difficult to process with usual tools, and distributed architecture needed. So out of all of these 3 points, the most important thing to focus right now is the distributed architecture needed. So whenever you find yourself in a situation where your tools which run on a singular system are not able to handle the data, and you do a bit of calculation and you say that even if I uh, I increase my hardware, we will not be able to meet up the requirements. Okay, we will have to anyway figure out, how can we divide the data into multiple ways and then use the distributed architecture. So that is the biggest characteristic of the big data. That's how it is defined. Okay, and the usual way of defining big data is this one. I do not subscribe to this, because if you see volume, velocity, variety, and veracity is is the definition of the data. It could be huge data, it could be any data. All right. So this is the IBM's definition, but it's important to note this definition because lots of people will consider that you don't know about big data if you don't tell them these 4 V's. All right. So first one is volume. The data should have big volume, or velocity. The data should be at a very high velocity. The third one is variety. Okay. Data can be in any form. It could be structured, unstructured. It could be multimedia or anything. Or data could be in veracity. Okay. So so veracity is something like, I mean, just for the sake of introducing one more V, they have added veracity. But let me explain that do they mean by veracity? The data in doubt. Okay. We know that data is inconsistent and we do not want to drop it right now unless we prove that it is useless data. Okay. Till that point of time, we might have to manage this huge data. And that's what the fourth characteristic of big data arises. Okay, so although this is basically a verbiage on words, okay, it doesn't lead to any of the output. It doesn't lead you to take a conclusive decision on whether I would require a newer tool or newer systems to handle big data or not. Okay, this definition doesn't take you anywhere other than make you look smart that I know these 4 V's. Okay, so just volume, when we talk about volume, we are talking about beyond terabytes of data. Okay, but in certain circumstances 1 GB or 2 GB can also become difficult to process on a singular machine, and in those circumstances even 2 GB can be considered as big data, or say not 2 GB, but say let's say 500 GB can also be considered a big data. Okay, so I mean, fine. So these are the 4 characteristics as per the IBM way of defining big data. All right. So it is good to know these definitions, but I will basically, I my role in the first half of the session is to help you figure out that in what circumstances you will have to say that this is big data and we require different kind of tools to handle this kind of data. All right. So so this is the basic definition of big data, but biggest important part is this third point. So whenever you realize that no matter how, I mean, even if I increase the hardware, I will not be able to handle this kind of scenarios. And the only way forward is using a distributed architecture. That point of time, you say that, hey, we need this is a big data. And distributed architecture means that, right. So just a second, I have to take a call. Okay. Okay. So is there an expectation, so there's some question which I'm reading out. Is there an expectation of how fast a query must execute? Okay. And right. So, I mean, that expectation is from your side. All right. Expectation is always a demand of your business. All right. And therefore, expectation is set by them, not by the tools. All you do is you figure out that this tool or these many systems are giving you this much of throughput, and therefore you might have to either change the framework you're using or change the tool, increase the capacity either by vertically scaling or horizontally scaling. Okay, I hope I'm able to answer your question now. So as a general icebreaker, because so how many bytes are there in petabytes? Any the first answer, I'll move ahead. So petabyte, how many, bytes are there in a petabyte? Excellent, excellent. So almost everybody understood. 1000 exabyte? No, actually. 1 petabyte is basically 1024 terabytes and 10 to the power 15. Yes. So almost everybody got it. Great, great, great. So this is just to get an idea. All right. So basically, this is how we remember the whole, kilo, mega, giga, tera, peta, exa, zeta, and iota. So this is how we remember uh, the table of, you know the memory. This is how the naming convention is. So a petabyte is 1024 terabyte, and a terabyte is 1024 gigabyte, and 10 to the power 15 is too many bytes actually. Okay. Now, one quick question to you, all of you, is 1 petabyte data big data? Based on the discussion we had till now, now we know how much is 1 petabyte. 1 petabyte is 1024 terabyte. All right. And okay. So do you think that 1 petabyte data, So yes, thank you. I mean, I'm actually happy that you understood what I'm trying to say. So generally the answer is it depends. So let's see uh, how it depends. So 1 petabyte data, can we handle this kind of storage very, very seamlessly using existing tools? And the answer is no. None of the existing tools provide you a great way of utilizing your 1 petabyte storage. And therefore, you require a distributed architecture system to store 1 petabyte data. And therefore, it is actually a big data. Yes. So most of the existing systems can't handle 1 petabyte of data, and therefore this is considered as big data. Now, okay, so I mean, most of the systems, if you think about it, their individual drives will be 1 terabyte of data, and having 1024 hard disks connected is only possible if you have a distributed architecture, and therefore 1 petabyte is largely considered as a big data. No matter the minimal use case of 1 petabyte data is just to store it. Even you don't do the processing. Even in the storage, you would require a distributed architecture, and therefore 1 petabyte is considered as a big data. All right. So now let's move on to the next reason. So this graph shows you that the big data, how big data has progressed, how the data has progressed, specifically the digital data. So this graph says that in 2002, suddenly the data explosion happened where people started accumulating and creating a lot of data, specifically after the internet became popular. Now, afterwards, the data has been exponentially growing, and in 2007 the digital data was 280 exabytes, and an exabyte is 18 zeros, okay, which is okay. So basically, right, so I mean, which means 3 followed by 20 zeros, and that was in 2007. And now you can imagine after 7 years how much will be the data. So this is a general graph which a particular agency has prepared. Now, the reason who develops these big data is basically these few reasons which we have pinpointed. First one is connectivity, and second one is devices. Okay, connectivity as in the various devices have become connected to each other, and people had got connected to the devices as well as to the other people, and they produce a lot of data. There is a temperature sensor which is continuously producing data, uploading to a server, and in these days even your I mean almost everything has started producing a lot of data and storing it somewhere. And on the social network you have Twitter, Facebook, and there are lots of other similar systems which have come up. They are also producing a lot of data. So the and by and because of the smartphones, people are able to use these services and people are able to produce a lot of data. So basically the devices and the connectivity, this is what had changed the way the data has been growing. Right? So these are the main reasons. All right. Now, when we talk about when we do computing, what are the four things that become the bottleneck when we are doing the computational, right? So, for a new person who is entering to the domain, they always think that either one of they have a perspective that say somebody is coming from a website background, they come up with they generally believe that only the RAM becomes the constraint, CPU never becomes a constraint, while people from research background, they think that only the CPU is constrained. Okay, those who are doing a lot of graph processing, for example, and doing a lot of small data processing, they think that CPU is constrained. While people who are just storing a huge data, they think that the device hard disk is a constraint. But as a matter of fact, most of the big data problems, all of these or either of these will become your bottleneck. And you, on a single computer, you try to resolve one, and as the data keeps growing, the other factor out of these four will become your bottleneck after some time. Okay. And so say for example, you figure out that your RAM was a problem. You kept an increasing RAM, and after some time you realize that your processor has become a bottleneck. And when you fix both of those, you may realize that your node network is now the bottleneck. All right. And that keeps on going. And when we put a distributed architecture in place, all of these four aspects are doubled. Okay. So effectively the effective capacity which you have doubled is 16 times. I mean, the effective capacity has become 16 times than the usual one. Okay, this is something very sounds surprising to lots of people, but that is the way a data architect or a data sciences person look at it. Okay, so Rohit is saying that audio connection is getting lost frequently. Frequently, is it happening with anybody else also? Yes, I'll send you the slide set. Do not worry. Okay, sure. Uh, reg id, somebody called reg id is asking for that. Okay, so yeah, for everybody else except for urja, there is some urja is also facing a problem with the id. Okay, okay, so everybody else is good with the audio, so I don't have to worry about it. So probably he need to disconnect. So Rohit, please disconnect and connect again, so audio will might become better. That's all I can think of right now. The general Microsoft way of solving problems. Right now, the first question which I want to pose to all of you. So first, whenever you're jumping into big data or any of these domain, you need to realize the reasons why are you going to use these tools. And I'm going to take you from with a very simple examples, and will convince you that these tools have some worth. Okay. These tools have some worth. It's not a fashion. Okay. Therefore, let me ask you a first very simple question. If you have 100 terabyte of data today and you want to store it, how will you store it? Or let me portray a little bit of story about 100 terabyte of data. Okay. Let me portray a little bit of 100 terabyte of story. So you have got your whole apartment complex where there are, say, 100 people living, and you decide that you will store all of your movies. You will build a cluster to store all the movies, where all of the people will be able to access and watch these movies. Okay, and you have, or say you have 5,000 people living in your apartment complex, and you decide to build a cluster on which the movies will be stored. And this cluster is basically located and maintained separately by the apartment complex. So you need to build this, and without saying that, without using the terminology from Hadoop or any of these popular Amazon EC2. So if you are given a task of building such thing using existing technologies, how would you build it? So Senthil's question is in a data center. Good, but in a data center, what kind of architecture will you be keeping? That is the question. The software and hardware, both, you need to tell me. So indexing will be there. Indexing, Suman is saying that indexing is required. Yes, we'll have to keep an index of which movie is on which disk. All right. Have minimal hard disk like 2 terabyte. Yes. Okay. And Vivek is saying that NAS with RAID config may provide excellent, excellent. So those who are not aware of RAID is basically a backup maintained on the same device. Okay, so when you write to one disk, there are two copies kept on the same device. Okay, okay. So another database to hold the indexes to the movie file. Good, good, good. So Vivek is saying that maintain all of these movies in a RAID based network attached storage. Network attached storage is where you attach these computers, these small computers in a network, and then each of these nodes become like a hard disk in a network folder. All right, so that is sort of a network attached storage, so you can have a lot of parallel computers attached at to a central system, and attached in the network, and they all are serving your all are serving like a single hard disk, right? So SQL server, t- 10 TB per table with index. Okay, okay, that's interesting. I mean, that's the first time somebody told me that. Good. Amit, that's Amit's answer. Keep a SQL server having 10 terabyte per table with index. Okay. Yes, Rahul, the session is going on. So my first question is, if you have to store 100 terabyte of data, how will you build the solution? Right? Great, great. So Amit's answer is interesting, and I'll have to think about it because generally most of these SQL servers, whenever you try to dump a binary data, it, it starts becoming, very costly. Okay, the licensing cost and the way you are going to slice your data, and then the way it is going to handle. You'll have to have 100 licenses of SQL server, and you'll have to do the division by yourself, and you will not get much in the return. Yes, Mega is saying a paid private cloud. So the question here is, say you are to build such, you are the engineer who is building a private cloud. How will you do that? All right. So now let me move ahead and probably when I'm taking up Vivek Juneja's answer. Okay. So we're building say network attached storage, and or say Akshay's answer where we have 2 terabyte, a 1 terabyte hard disk. Okay, and buy such 100 1 terabyte drives and make a network attached storage whereby one drive, two drive, and up to drive number 100, they are attached, okay, and are displayed like a folder to you, right? Right. Now, do you guys see a problem? So basically, drive one may be having a local copy of drive one, uh, and say drive one, which will just keep a backup of everything stored in drive one, right? So these are basically, when I say drive one, drive two, drive three, drive four, they are basically network attached computers which are serving like a hard disk to you. All right, and this is we have installed a NAS or SAN based central server, which is basically mapping these hard drives. Now, do you see any problems with this kind of arrangement? Do you see any problems with this kind of arrangement? Excellent. So Vivek Juneja's point is that finding where the movie lies. Good. So what we'll do is on the main folder main folder itself will maintain a simple, very simple, sort of a small MySQL instance in which we'll just crawl all of these drives and keep on updating that MySQL. Okay. So whenever people come in, they look in the MySQL database and then, or some other, say, plain text file, which just gives a list and which drive it was found. Okay. Good. Good. Akshay is saying money constraint. Okay. Okay. That's a very good point. Very good point. And yes, and actually finding which where the movie lies is also a very good point. Searching for data becomes time consuming. Yes. Thank you, Rajnikant. Communication with the main folder. Yes. So main folder basically doesn't do anything, Amit, in these cases, right? They generally direct your request to that particular node which is storing your data. Okay. So that might not become a main issue, but it does become an issue after some point of time when the main folder starts behaving a lot. I mean, it start taking a lot of integrity problems. So yes, does the data grow? Yes, data will keep on growing, Vivek. So every now and then new movies will keep on coming and people will keep on adding the data. But that's a very good point. So whenever somebody throws a question like this, you should be asking a question like what is the data growth pattern? All right. So those are the questions you should be asking to the guy who is questioning. And even if in the future you are designing a similar system, you should be asking a lot of questions. Main folder will become the bottleneck. Yes, it does become a bottleneck. If one system is down, then the data is lost. Very good point, Karthik. So even if we have a RAID on that machine, if the network connection is lost, the data is actually lost. I mean, people will not be able to watch those movies stored on that machine. And this is not a very, mm, you know, unforeseen scenario. It is a very common scenario. Thank you, Karthik. Yeah. And facing problems in accessing. Yes, very good point, Ayush. And that is something Akshay has also raised the same point. So basically, yes, that is something which lots of people miss out. Accessibility will become a problem. Okay, that's interesting. So Kavita is saying that what happens when movie is in multiple drives. So I mean, in current scenario, the current scheme of things, we did not plan to split a movie and put it on the other drives. That was not possible. Each drive pushes file information to the main folder when new movies are added. Each drive pushes, yes. So every time we add a new movie onto drive 1, drive 2, or something, the main folder gets updated with the number of files. We keep maintain an index on the main folder. Right. Now, in this architecture, there are few problems, and this is how actually we maintained the data for quite some time in our data center. All right. So we used to buy a lot of hardware, put them into various computers, and creates a great RAID on each device and put that into the network and let people and map various directories to various folders and we divide the users. Some users go on this drive, some users go onto that drive, and so on. We keep on doing this sort of magic. And there were a lot of issues with this kind of system. First one is the failover and backup. So first and foremost problem which somebody raised that so the problem which RAID solved, the redundant drive on the same machine having the backup of that particular hard disk, Basically, the problem that is solving is the failure of the hard disk. While that is a very most prominent reason of failure, there are other reason of failures too, such as operating system problems, such as network related issues on that machine. Okay, so the failure of a single node is also very common phenomena other than failure of a disk. Okay, so failure and the backup, or I mean failover, as in case that system dies, do we have that file available from somewhere else? Okay, so that becomes a very big bottleneck. Now you will have to design something like two computers maintaining the same copy of the same data. So that will be the addition into the our architecture. Now the other problem is, how will we how will we distribute the data uniformly? How will we distribute the data uniformly? Meaning, in what pattern are we going to divide the data? Which movies will go into the drive 1, which movies will go into drive 2, and so on? Or we just start filling it from top to bottom, and then whenever there is a request to access, and keep on updating our index. Okay, so there are multiple ways. Now, but in most of the cases, a lot of human intervention will be required to divide the data amongst various servers. So let's say we come up with this plan that all the movies starting with A will go into the first two servers, and then starting with T will go into this, and C will go into this, and so on. And after some time you will realize that the schema is not sufficing, and therefore we might have to keep on updating schema and keep on moving the files from here to there. And and in case there is a huge file and there is a space on one machine where it can fit, only half of it can fit and half of it cannot fit. And in those circumstances, it is not possible. So the slicing, so we might have to even divide the files into half, right? And as somebody said, I think Akshay said that. Okay, so that was the first question. Akshay said that money constraint. Yes. So both the cases. First, we are buying 1 terabyte drive. Maybe in the industry, right now in the market, we are getting 500 GB smaller hard disk for cheaper price. Second, we might have already a lot of 100 GB, 200 GB hard drive lying in our organization or with us. Can we utilize all of those? But in current scheme of thing, if we are not dividing the files into small pieces, then we may not be able to do that. All right. Now, the fourth point, last point is very, very important, and probably all of the systems kept on ignoring this. Okay, kept on ignoring this for quite some time. Okay, now say a new movie came in, and everybody wants to watch that movie. Okay, and we don't know how popular is this movie and how many people are going to watch it, but anything could happen here. Okay, so maybe suddenly it's somebody's birthday, some TV star's birthday, and everybody wants to watch a particular movie by that TV star, Amitabh Bachchan's birthday, and everybody wants to watch Amitabh Bachchan's favorite movie, and we all, that particular node, have the huge request from your users, and the node which was storing that movie is going to go down. Okay, and therefore accessibility becomes a big concern. So consider the grid. Okay, I've got lots of more points. Okay, Kavita is saying what happens when movie is in multiple drives. So movie is in multiple drives. That means that you'll have to divide the file into pieces and keep it. And normally that is not supported by existing systems. Each drive pushes the file information to the main folder. Okay. Would organizing those movies according to size will make it more efficient? There would be challenges with that also, and there are other challenges. If you think about it, there will be other further challenges with that. Okay, I can get into the details. And Giriraj is saying consider the popularity of data and distribute equally the most popular m- movies into all the systems. That's a very good way of thinking, Giriraj. But right, but generally you cannot figure out the popularity right away until and unless you build a historical information about the user's behavior, right? So you generally do go with a very rough estimates, and they always fail. All right. So, and also in lot of ways, I mean, what Giriraj is saying that say movie is the very popular one, so copy it on say 50% of the nodes, right? And if say out of 100, 50 nodes are having that movie. So in most of these circumstances, we end up wasting a lot of space, which is not required. And this approach was there, and lots of people were actually following that approach. Okay, we were following that approach in case of maintaining the videos. I mean, I'm being very honest with you. So yes, that's a very good way of solving a problem. But there are, I mean, it wastes a lot of space. Okay. Can we design an algorithm to save data so that, yeah, so say let's assume that most of this data in movies is already compressed heavily, right? And the compression further cannot happen without a data loss. Okay, and therefore compression right now is an you can assume that this is already a compressed data, and we are trying to design that kind of thing. Okay. So, no, so what people did was, after thinking about all of these problems, they came up with something like her Google file system, and that Google file system was similar to, I mean, it has been copied and has been implemented in open source by Hadoop guys. It is called HDFS. Okay, in a very simple way, all it does is it will split your movies into small file, small pieces, and distribute it onto all your 100 computers. Okay, so if your movie is divided into 100 pieces, so all those 100 pieces are stored on 100 computers in your network. Okay. Now, whenever there's a movie request, it comes to a system, and whosoever is accessing it will be provided with an interface which can easily combine all of these pieces and give the movie. Which means that now it is similar to what Giriraj was suggesting, just that instead of copying the whole file, we are just copying uh, putting one chunk of the big file onto all the nodes. Okay. Now, on in addition to this, each of these chunk is having two more copies, which means if the computer having one piece of the file goes down, that same piece is available elsewhere. This is the very simple definition of HDFS. Now, if you think about all the problems we discussed, HDFS actually is able to solve all of those. We'll go into the details very soon. So I just okay. So Anima, so the way we face these problems, these five problems we faced: failover backups, how will we distribute data uniformly, and all that. So what Google guys did was published a paper, and that paper was implemented by Hadoop guys. And the way it works is the HDFS, which is Hadoop Distributed File System. The way it works is it will take your one movie, and then it will split it into small pieces, store it on all 100 nodes, and on the main node, on the main computer, it is going to keep this information that which piece is where, and that it is going to do the same thing for all of your movies. Now, in case there is a one popular movie, the load is going to be distributed equally to all the nodes on 100 computers. So first 5 minutes might come from the drive 1, next 5 minutes are coming from the drive 2, and so on. And this interface which will switch between these pieces or combine these pieces for you is basically a client library. Okay, so the library with which you will be using this network will do this joining, splitting for you, and store the data onto these nodes. Okay, so that is what an HDFS is in very simple words. And each of these pieces, when it splitted your files and distributed the pieces into all the networks, it also created copy of each piece. We call a piece a chunk also, and we'll be using the terminology chunk and piece interchangeably. Okay, so each of this chunk is basically copied and replicated to the network as well. Two more copies are done, and in case you find that the particular data is more important, you, while storing the movie onto this cluster, you can specify that this data is more important, keep more copies of each chunk into the network. So that is the basic use case I'm trying to pitch in for the HDFS. Okay, if one system fails, then how we get that piece? Right. So Amit, that's a very good question. So let me again repeat what I just said. So each piece is also copied onto more than one node, more than one computer. So in case that computer is down, you are still left with two more copies. And the moment it is found out that one computer is down, this file system will immediately make the pieces which have just lost, he'll start creating the copies of those pieces onto another machine. Okay, so Rajnikant's question is that this is how torrents work. So this whole idea is actually inspired by torrents in parts, but not really a peer-to-peer. Okay. Yes, so copies are consuming extra space. So in effect, you are consuming 3x of space. Okay, three times of space. Because by default, we are saying that each piece is being copied, having two more copies, which is three times of space is being consumed. You are right, Megha. So so I just explained to you a file system called HDFS. I will go into the detail in the second half. And here I'm trying to convince that there is a big utility in having a HDFS kind of file system. What if there is a failure while fetching a node? Okay, so the moment it is found out that a node is having an error, you go to the another node which is having the same piece of data, and then you can handle that. All right. How will we decide on failure which system has copies? Okay. How will we decide on failures which system has copies? So no, I did not get Amit your question. Probably you could reframe it quickly. What if there is a failure while fetching the node, even in the secondary node? Yeah, so you go to the tertiary node, and immediately there's the third one. The only possibility is that all the three nodes on which a file was stored, okay, so it is split the whole file into say 10 pieces, and all of these 10 pieces are having three copies. So there are 30. 30 small pieces stored in the network, and each piece is having two copies, right? And in case all these three nodes containing this piece and its copies are all of these lost, okay, all of these somehow they got down for some mysterious reason, in those cases your data got lost, okay. But the probability of that happening is really very low. If you combine it, if you multiply, because the probability of all three going down simultaneously same minute or same hour without you noticing it, or without HDFS noticing it, because the moment one node will get down, HDFS will make a note of it and start replicating the data. So immediately all three nodes going down is a very rare possibility, specifically because when it stores the data, what it does is the first piece is closer to the user and second and third pieces are far away from the user, which means maybe in another data center altogether. So the copies of a piece might go into another data center, and therefore even if one data center burns down, there are high chances that you still have the access to your data, okay. So the possibility of losing all these three is very low. So am I able to answer your question, Amit? Okay, so maybe you will get more clarity when I discuss in detail the HDFS in the second half. Till then, let's move ahead. And I will now pose another question. All right. Another question to you is that if you have 1 terabyte of data, specifically you can think of 10 billion names of things or people having 100 characters each. Okay, you have to sort these numbers. You have to sort these strings. How will you do it? Sorting means ordering things by ascending or descending order. Yeah, it can be alphabetic or maybe numeric, or you can think of alphabetic only for time being. Now, how much time do you think it is going to take? Just give me a rough estimate. Just do your, throw in a number. You have got 1 gigahertz processor with 2 GB RAM. Okay, and you have got this 1 terabyte of data which you want to sort. 1 terabyte data is basically 10 billion names having 100 characters each. So Akshay is saying 5 hours. Anybody else? Just give me a number. Just give me any number. So Kavita is saying 1 hour. Around couple of hours. That's Vivek's question. Never. 15 to 20 minutes. Okay. 20 hours. Excellent. So as you go back, right? So first step is to generate this kind of data. And then the next step is try to sort it. And this will be a very interesting exercise if you try to take this challenge, right? So I was not sure. So Amit question is saying that depends on algorithm. So think about it as a merge sort algorithm we are going for. Okay. Akshay is saying it will go for 10 plus hours. Okay. Okay. So see, I'm asking you because most of us think that the computers are really fast, and we find it very difficult to basically compute this kind of thing. Actually, being honest, I also thought that it is going to take a far lesser time, but it took me around 5 hours. Okay, and the way I did it. the way I did it is slice the whole data into 2 GB sizes. Okay. And then I used a command called sort on Unix to sort that data. And then I merged all of that data by using sort minus m and that particular data. All right. So that whole process, even after parallelizing a lot, it still took me 5 hours. And from my computation, it cannot be improved further. Now, when we do as a computer scientist, when we do the numbers, we realize that this will take far lesser time. If you do a simple n log n and try to do how much computer cycles are used, and you figure out how much time does it take to compare these many records, the time comes out to be far smaller. Time comes out to be far smaller. But why did it take 5 hours is because when we were reading from disk, the disk read write has actually taken the maximum time of the computation. Okay. Even after parallelizing, right. So as Karthik says, since the data has to be loaded to the primary memory from the disk, it is going to take time, and therefore it takes some around 5 hours for me. Okay, so this was just a random thought. And why I'm asking you this, that basically when we say handling lot of data, so handling lot of data actually means storing and processing. So the first aspect was storing, and HDFS solved it. And when we talk about processing, processing is basically ordering of the data. All right, and we the overall objective. So when we say processing, processing can be of lots of aspects, lots of forms, but sorting is one form of processing which is very popular, which is you know which solves a lot of problems. Let's take a case of say your select query, and select query is looking up in the indexes of a table, right? Now indexes are nothing but your the way you have indexes at the back of the book. So you, instead of looking, if you're looking for a word, you don't go looking in the whole book. Instead, you go to the index and just quickly locate in the index and find out the page number and jump to that page number, right? So indexing, basically index is a sorted values. Similarly, a dictionary, when you look in the dictionary, it's a very quick to find a word, because in the dictionary the names are ordered, and therefore a sorting of the values has helped you locating a word. Similarly, in a select query, when you say select star from something and where this equals to that, is going to use an index similar to a dictionary or the index at the back of the book to find out a record. And this is heavily aided because of the sorting. So sorting solved your first select query. Now think about a simple order by. Order by is again a sorting problem, right? And similarly, when we say group by clause, group by inherently is a basically when you say group by, all it does is it first orders those values, and or it looks up in the index which is anyway ordered values and then gives you the data. So group by is essentially a sorting problem again. And similar is when you join two tables, right? So most of the processing as we define it is generally an issue of sorting. Okay, so sorting is one such issue which everybody is trying to compete and trying to solve it and make it faster and faster, and make it faster and faster. And therefore sorting is one thing which Hadoop also solved. All right, so sorting is I mean, right. So processing, when we talk about processing, it's generally about sorting the data. And Hadoop MapReduce helps you in that. Okay. Now, these 5 hours, they sound like a very great idea. Like it sounds like sometimes for lots of us, 5 hours is good enough. But at in lots of problems, we need to decrease this time of 5 hours to maybe 5 minutes. In those circumstances, no matter if you start increasing RAM, the disk was anyway the problem, right? And how do you solve the problem of disk? By putting SSD or solid state hard drive to make it faster to read from the disk. That too will make it, maybe from 5 hours it might become, mm 3 hours or 2.5 hours, but not 5 minutes, right? And therefore, you need to figure out a way to sort the data, sort this kind of data largely. Okay. The other problem with these 5 hours is we might have to sort a bigger data. So in case the data goes from 1 terabyte to 2 terabyte, do you think the time will go from 5 hours to 10 hours? It will be generally more than 10 hours, right? It will generally be more than 10 hours. And therefore, right, the other third aspect is that we might have to do it more often. Maybe every 2 hours we might have to sort the data. And therefore 5 hours is not good enough for us. Therefore, considering sorting as the main aspect and considering all these constraints which single computer was forcing us, lots of organizations including Google had been competing in a competition called, where they compete in how fast they can sort, which is called sorting benchmark. Okay. Sortingbenchmark.com, probably. I need to, I forgot the name. And in 2011, Google said that they are able to sort 10 petabyte of data in 6.5 hours on 8,000 computers. Okay. So basically, to make it faster and handle a bigger data, they utilized 8,000 computers, and that is just marvelous, which was not really possible to do it on a single node. So therefore, 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 we require a cluster like MapReduce, which basically inherently is a is a is a framework that sorts the data. Okay, so basically, MapReduce is a framework that sorts very huge data. All right. So by the way of writing two functions, one is map, other is reduce. You tell MapReduce framework that these are my keys and these are my values, and MapReduce takes the data, orders that, orders it by the increasing order of the keys or whatever form you have given in the keys, and then groups all the values of the same key and give it to your reduce function, which is executed on each key and output is given. But the most important aspect of MapReduce is that whatever keys your map function is spitting out might be in hundreds of petabyte of data. Okay, say you are handling a big file and your map function is taking each word and spitting out a key to the MapReduce, and MapReduce is going to sort this 1 billion 100 petabyte of data to give you the results. And therefore, uh, uh, and and therefore it makes it possible to solve big data problems, right? We will not hit this kind of limit that we are not able to go beyond 5 hours while handling 1 terabyte of data, right? And so now let's talk a bit about big data customers. So I just talked about two aspects of computation. One is storage, other is processing. in processing, I specifically discussed only the sorting problem, because most of the problems we can convert it into a sorting the way I described. That SQL itself, SQL filter, I mean, when we say select where clause, looking up in the indexes, group by, order by, joins, all of those problems are inherently a sorting problems, right? So sorting is basically the mother of all the processing needs, unless otherwise, unless you are uh, handling map kind of problems. There are other problems also other than the sorting which need to be addressed, but most of the other problems could be, broken down into sorting problems. All right. Now, so who are the people who encounter this kind of data, and who are the people who encounter the processing need of this data? The answer is all of us. Answer is all enterprises. It is just that we are not looking in the right direction. Lots of organizations are not looking in the right direction, and therefore I want to give couple of examples which people had been doing. And the first section is based on my own personal experiences with Amazon and in Mobi. Okay. So at Amazon, if you go to Amazon.com, you look at it gives you recommendations. There are various kinds of recommendations. People who liked this product also liked this product. And there's another recommendation called you may also like this. Okay. So these, and Amazon has found out that these recommendation improved improved the chances of a customer buying from Amazon. And therefore it it is very very important for Amazon to build the best recommendation engine. And to build best recommendation engine, they need to churn a lot of data, users behavior they need to understand properly before giving the best recommendation, right? In recommendation, the bigger data should be better data for you, because say there are two users who are similar to each other, right? So we can give recommendation of one person's choices to the other person, and therefore the bigger data you have, there are higher chances of finding a behavioral pattern or clustering users together, and each cluster will have sizable amount of users, and therefore the bigger the data the better it is. And recommendation engine is one very very basic use case of big data. So I mean, that is why we also we give an example of recommendation engine in one of the classes, which you can basically how to build a recommendation engine in 10 minutes. That kind of demo we do in one of the sessions while talking about Mahat. And the other problems are ad targeting. Which ad should go to who? There are billions of devices, billions of people playing the games, or you can think of like millions of people playing the games, and which means there are millions of ad spaces, ad slots available for you to stream the ad. And what kind of ad do you show where? That is ad targeting. Search quality is a very very big problem, as it seems in 1990s we thought that search is a very very simple problem, and users were not happy. I remember my days. And in case of search quality, there are lots of things such as plurals, such as typing mistakes, such as figuring out various mutations of a word, such as, say, when I say big data, there could be a space between big data, there could not be a space between big data. And to figure out such kind of plurals, you might have to crawl half of the internet just to figure out what are the various variations of each word, right? So search quality inherently is a big data problem, because you will have to do a lot of churning upfront as well as on the spot. And the next one is sentiment analysis. This is like a very cliche in today's time, but uh, sentiment analysis matters a lot for almost every brand. Now there are a lot of tools which does the sentiment analysis for you. In very simple words, sentiment analysis means understanding the sentiments of people around your brand. So let's say that you have got a product out today. You got a say new release out today, and you are basically monitoring Twitter about the negative and positive words which are being said by various people in the context of your product on Twitter. So you crawling all the tweets of from the Twitter, and noting down all the negative and positive words used with your product. Okay, and you keep on plotting this graph of negative positive keywords, or ratio of positive divided by negative keywords, and you keep on plotting this graph, and just to note down that did this particular release or this particular branding improve the sentiment in very simple words is negative words said about you divided by positive words said about you. It's as simple as that. And so sentiment analysis has become very, very important aspect for almost all the brands. Even for companies like us, which are very small, it has become a very, very important aspect. And click fraud detection and abuse, say for example, people are just you are doing Google AdWords, and lots of people, all they're doing is clicking on your ads so that your budget get lost. So Google does a lot of click fraud detection on their website, in the search results as well as everywhere, to figure out the click fraud. And similar is the case with companies like Amazon, because they too have a lot of advertising space here and there. Right. So this is only possible if you have a lot of historical data of people's behavior, and then you map it with various kinds of people, map it with the current behavior. So let's say from the history you figured out all the people who come up onto your page by a single click and then close it within 3 seconds are people who are basically fraudsters. So those kind of patterns you can only figure out if you are churning a very huge data. And similar is the case of customer churn prevention, in which you can stop a customer from leaving you because of certain problems. And you can actually go into the history and figure out why did customers leave you. If you can figure that out, you can stop the customers leaving from you. In telecommunication, they use it. And all of these examples, I've taken them from the Hortonworks website and Cloudera's website. So these are basically the use case of Hadoop in practice. This is not, we're not talking about the future. This is the present we are talking about. Similarly, we have government healthcare services who are using big data solutions as of today. There are billions of examples which is in practice already. Okay, and there are many more. And these are 11 common myths. And in case you have a doubt about any of this, so probably a lot of people will have a question about the third one. So this third one is the most popular myth. It will replace enterprise data warehousing. Okay, EDW is enterprise data warehousing. In fact, it does not. EDW is just another it will not any of these big data technologies, whether HDFS or Hadoop, MapReduce, or Bigtable, or whatever you can think of, they cannot do what EDW does, and vice versa, right? Enterprise data warehousing is specialized in handling a transactional data, where a record is very well represented and the relation is very well maintained. That is not yet possible using any of the existing NoSQL databases, and therefore it is a myth as of today that any of the NoSQL database is going to replace MySQL. I mean your existing database technologies, right? So so if you have any doubt about these 11 myths, you can ask, right? Now these are other questions. You can anyway read it. And this is a very quick slide where I have done a bit of analysis about various kinds of jobs in this domain and why big data is important based on Gartner and Forbes analyst reports. You can go through it. I will send the PPT to all of you. So nothing to worry or no need to take the notes. Okay. And now after the break, we'll talk about what is Hadoop, all right? And we'll go into the details of Hadoop after the break. We want to take a small break. Until then, you can actually note down your questions, or maybe if you want to have dinner, you can have the dinner, then come back. All right. Now, let's have a 10 minutes break now. Okay. Is that all right with everyone? Right. So let's meet at 10:12. Okay. All right. So let's just drag it here. Hey guys, I'm back. I'm little uh, okay. Okay, so I'm sorry for being a little late than usual. Right. Right. So so we're starting now, and we'll discuss with the Hadoop in detail. Is everybody back? Is great, great. But those who are not back, they will how will I know? Okay, excellent. So let me have a look at the. Okay, yeah, I think we are good to start now. So Hadoop is basically a framework of components. Okay, this is an umbrella term. It started with two basic components. One was MapReduce, other was HDFS. One was for storage, other was for sorting. Okay, and distributed computing. So, but slowly, lot of frameworks are being added to the uh, Hadoop, umbrella. And all of these products which are being added to Hadoop umbrella are basically the point number E are reliable, scalable, and distributed computing. So Hadoop is basically umbrella of the products. Okay, and rest is just a history. You can go ahead and so basically there was a guy called Dog Cutting who was working at Yahoo and he was building a search engine called Nutch. And for that, he required a lot of things which actually Google also required. And Google had published various papers such as Google File System and then Google MapReduce and Google Bigtable and all of those. So these guys basically started implementing those in order for their search engine project to work. And afterwards, it became quite popular, and lots of people started using it. And they made it completely open source. And they wrote it in Java so that it can run on lots of different kind of machines. Okay, because the idea was to utilize lots of machines. Okay, so for working, you need not learn Java per se. But it's good that, but you should know at least one kind of programming to attend this particular session. Whether you know Python, whether you know Java, or you know C, C++, or any of the programming language you should have done in order to like this particular course. But luckily nowadays that for using Hadoop, there are data scientists who don't know Java. There are analysts who don't know either Java or Python or any other language. So all of them are able to use Hadoop in their own manner. Okay, so it all depends that how are you going to use it. All right. C sharp is as well is good because you'll be able to correlate very quickly in case C sharp is very close to Java and the C sharp version is still to be done, although Cloudera has launched a Windows version of Hadoop. Not Cloudera, Hortonworks has launched a Windows version of Hadoop, but still that one is requires Java as well as but most of other tasks you can do using any programming languages, and there is a library which lets you use any programming languages. It's called streaming. We'll talk about these in details, but Hadoop is basically a full stack of components, and and in the software industry field there are various profiles, and according to that there are various components who people can use. Okay. Like for example, Piglatin is there. It's a completely new programming language, right? And yeah, so it is not. I mean, it is written in Java. That does not mean that to use Hadoop you need to know Java. So there are two core components of Hadoop. First one is HDFS for storage, Hadoop Distributed File System, and second one is MapReduce, which is basically for distributed computing. Okay. And so MapReduce has got two properties. First, it distributes your logic, whatever you write in MapReduce, onto multiple machines, and then execute it parallelly on all the machines, and then give the results back to you. All right. So all the map code you're going to write is going to run on all the machines. And so say you write a function, you write your class which defines the map function, or you code your program in say Python or maybe shell programming, and then copy it all to all the nodes. And that when you say execute this, it is going to execute your logic on all the computers parallelly, and whatever the results it is going to combine that and give you out. Okay, we'll go into the details of MapReduce engine later on, but for time being, understanding this much, that it executes your logic, whatever logic you write, on multiple computers in parallel. And the other aspect it takes care of is that whenever you execute a logic, you also tell that, okay, this is the file which I'm going to churn. This is the file my logic is going to utilize. And that file, if it is on HDFS, you can basically that file has to be on the HDFS. So it will be sending your logic near to the piece, near to the pieces of your file. Okay, which means that there will not be any data transfer required, right? Earlier what used to happen is the we used to our code used to bring the data from server, do the processing, and store it back to the server. Now there is a lot of transport expenses in between. This was good enough and acceptable till the point we had smaller data. But when it comes to big data, the transport itself becomes such a huge liability and such a huge burden that it becomes impossible to do processing just because data transport is impossible, right? Therefore therefore instead of transporting the data, transfer the code, take the code to the data, instead of bringing the data to the bringing the data to the code. It's like taking the x to the tree instead of bringing the tree to the x. Okay, and that's the thing which MapReduce does. So whatever logic you write, it goes near to the chunk where your file is being stored, on which your logic has to apply. Okay, and and it has to be executed. So 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 that there is no data transfer required at all. Okay, we will talk about it in details further. So do we need an IDE to execute logic or program on different node? Not really, not really. You will build your binary in whatever form you do, using whatever programming language you do, and hand it over to Hadoop and tell that this is how it is to be executed. All right. We'll go into the details of basically two parts. One is called streaming way, in which any programming language is accepted, and the other one is specifically for Java. So one of the sessions, session number 3, just deals with only the Java. Half of the session is devoted to the Java, and rest is for all the in a generic programming language. Okay. Now this is the general diagram of Hadoop. This is the general diagram of Hadoop. Okay. Now in this diagram, the base one is the file system where we are going to store all the data. And this file system, if you remember, is HDFS, in which each file is divided into small pieces and stored on various nodes. That is called Hadoop distributed file system. So all of the components use the HDFS, while HDFS doesn't use any other components. Therefore, it is considered as the base of the whole ecosystem. That is how you define the base. Now, second part of the Hadoop ecosystem is MapReduce. MapReduce basically, is dependent on HDFS. Okay, so to have MapReduce, or to use MapReduce, they have to have a HDFS somewhere. Alright. Now, MapReduce basically helps you execute your code parallelly on multiple computers and get the results out. Now, the next one is HBase. HBase is basically a database. Okay, so your compute engine, the heart, which does the computation on top of a storage is MapReduce, while HBase is NoSQL database. NoSQL as in it's not a relational database. It cannot guarantee you all the properties of a database like ACID properties of a transaction. It cannot do that. So how many of you know the what is ACID properties of database? Quickly, just anyone? ACID properties of a database, ACID. Okay, so every relational database guarantees you. Okay, so Kavita is saying A for atomicity. Okay, and C for consistency. Okay, durability, and I for anybody? Isolation. Perfect. Okay, I for isolation. That's a general way where we say integrity, but yeah, no D for no D is not for deadlock. So basically, ACID is the properties which relational database used to promise, where if you write the data, it should be durable, it should not get lost in the air, and atomicity, as in when you either the data gets written or it doesn't get written at all. Okay, either of the two states should happen. It should not happen that half of the data is getting written and it is visible to all the people, or there should not be a middle state anywhere. That is atomicity. And consistency is that whatever you wrote, the moment you wrote, if the next request comes to the server, exactly the same data should go. So these properties of ACID properties are not actually possible to be by any of the database which is runs on the distributed architecture, because there are multiple nodes, and in case you make one node for only reading writing and rest of the nodes as backup, then there will be that node will become bottleneck. So to avoid bottleneck, what people do is you write to one node, read from another, and we sacrifice the consistency, or we sacrifice the availability, and those kind of things. So basically what I'm trying to explain is that there are new kind of databases which runs on hundreds of nodes parallelly, where your table is automatically partitioned. Okay, they cannot guarantee you the ACID properties. If you think about it, you will be able to figure out why they are not able to do the ACID property guarantees. Okay, and they do the automatic division of your data based on your ID, and hence every table in a NoSQL database is is supposed to have an ID, right? So these are the new generation of the databases which runs on the distributed computing, which are called NoSQL. But uh, they have their drawbacks. Okay, so in case you have a small data, you should prefer the relational database per se. In case the data is not being handleable over there, In those cases, you move to NoSQL databases. So Amit's question is interesting. I'll answer you. They just give me one more slide space. And his question is, in HBase, can we query through SQL because it's a database? Okay. Yeah. So you'll get the answer. Now the next one is Hive. Hive is the SQL interface for the whole game, right? So basically, when you write any queries in Hive, those gets convert, and using Hive you can actually query HBase. You can also query HDFS as if it's a table. Each file is a table. Say you have a CSV file is stored in HDFS. You can use SQL query on top of that CSV file to query data from over there, right? And any query you write under the hood, it gets converted into sequences of map reduces, which gets executed on HDFS or on HBase, right? So Hive is your SQL interface, your gateway to to the system via SQL interface. The other property of Hive is that it can, other than connecting or providing you the SQL interface to only only HDFS and HBase, it also provides you the SQL interface to the other NoSQL databases such as MongoDB, such as say Cassandra, and it also provides you a gateway to existing relational database. So in Hive, you can have one table from HBase, other table from MongoDB, and third table from relational database, and you can join all these three tables and derive the output. So Hive acts as the gateway, and it's a very important tool for lots of data analysts. Okay, so am I able to answer your question, Amit? Okay. Now the next important aspect in the whole game is Pig Latin, right? So basically, some of the researchers realized that Hive is basically not basically the SQL is not really a great efficient. SQL is not really very efficient when dealing with big data. Okay, because SQL was from bottom up designed for relational databases, and therefore SQL they were not able to build constructs on top of SQL to provide a highly efficient system for distributed programming, and therefore they write a sort of the brother, or you can say a cousin to Hive, which does which looks like SQL. Okay, and this cousin is called the Pig Latin, which looks like SQL, and which in most senses it will behave like SQL, but it is far more simplified than SQL. And in my experience, all the candidates have been able to pick up Pig Latin very fast, even those who had no experience in SQL, and also those people who had been experienced in SQL. When I gave them a problem, they preferred Pig Latin over SQL. All right. So Pig Latin has been really successful um, data query language, and this is quite useful. It under the hood again does the same thing. Any statement you write, it is broken down into various sequences of map reduces batches, and they gets executed on multiple nodes in the HDFS. And this one, the Mahout, is the biggest value addition. Yes, you can use Hive because Hive supports the JDBC interface. All right. Hive supports JDBC interface. And JDBC is supported in MS SQL. That was Akhilesh's question. That can we use Hive on MS SQL? Answer is yes, via JDBC. Right. Now, The most important aspect is Mahat. Mahat is somebody who rides the elephant, right? Mahat is somebody who rides elephant, and Hadoop is your elephant. So Mahat is basically a machine learning platform that used to run on top of Hadoop earlier. Now it is independent. It runs some programs on top of Hadoop, and some program it does its own way. Most of the very and it is basically a library of various functions. The way you have math library in almost every programming language, similarly Mahat is available as a Java library. Also Mahat comes with its command line, in which in case you don't you want to call it via system call, or you want to pipe the data to those example programs, then you can do it. Okay. In case you are not coding in Java, you can directly call Mahat from the command line, right? So Mahat is basically a collection of algorithms. Around 50 algorithms are there, related to clustering, related to recommendation engine, related to various predictions and all sorts of data. So Mahat provides you those kind of algorithms related to machine learning and statistics. So Amit's question is that we have to use Hive, Pig, Mahat, all three, or any of those. So it all depends on what you are trying to accomplish. So Mahat is basically a library of functions. So it is not really an alternative to Hive and Pig. Just that in this diagram I have put them in the same color. But the choice will generally have the Hive and Piglet in between the two. So your question is basically related to, do we have to use Hive and Pig Latin or either of them? The answer is you can use either of those because they are basically similar to each other. Okay. And they are trying to accomplish exactly the same thing. All right. So mostly people who are very comfortable with SQL generally go with Hive as is. People who get acquainted with, sorry, the people who get acquainted with Piglatin, they generally prefer Piglatin. So that will be your choice. And okay, so and then there is Uzi. So okay, let me before going to Uzi, let me talk about these two guys also. So there is Flume and Scoop. They are underrated tools, which are basically to do lots of data import from various forms. So Flume basically copies a lot of text files from all of your servers together, and it flows to the HDFS. In case you have a cluster which is running Apache servers and you have a lot of Apache logs in the network or any kind of system activities in a unstructured form. So it takes all of that data and puts it in HDFS. Now you have second form of import tool called Scoop, which basically takes structured data and puts it in HDFS, HBase, or or say in other formats, right? Basically, main are two, HBase and HDFS. Okay. So Scoop helps you taking import from all of these systems into import the relational database from MySQL, MS SQL, or other sources to HBase, Hive, and HDFS. That is the role of Scoop is, meaning the data import export of relational data. Okay, structured data, not relational, structured data. While Flume is for unstructured data such as Apache logs. So now when you build a project in which you will be importing some data from MS SQL, MySQL, and some data might be coming from your plain text files. Some data, and then once you are done with that, you might be moving some of this data into HBase, or you will do certain rudimentary computation on HBase. and then you will be using your pigletin for doing some aspects of it. And later on, you might, once you have, formatted your data in a great form, you will be running Mahout libraries to do various kinds of magic on top of it, such as building recommendations. For recommendations, you need user ID, which user liked which product, how much. You'll have to form this kind of clean input. To do that clean input, you will have to do pigletin, you might have to do some sort of HBase, you might have to import data before doing that, and you might have to write your own MapReduce logic also. So to combine all of these together for a project is the duty of Oozie. Oozie is a scheduler as well as a workflow. So you write the sequence of steps and then give it to Oozie. Oozie runs it on your cluster, right? So that is the role of Oozie. And then there are various clients. So this is more or less what we cover. Other than these components, there are more components we are going to cover also, which are, one is Apache Spark, and one is Apache Spark, other is Yarn, and other is Zookeeper. So those are the more tools will be covering in this session. All right. So this is what a Hadoop is, right? So these are basically a suite of components which come together with this. Now let's talk about the core components. The core components, as we discussed, are two. One is MapReduce, other is HDFS. Okay. So so a quick question from the discussion till now. So MapReduce engine depends on HDFS or HDFS depends on MapReduce engine? Quick. Who depends on who? Great. Okay. Okay. So Amit is probably having his bank account in HDFC, and that is the reason he has typed HDFC instead of HDFS. Because I also do that mistake quite often. And right. So yes. So basically, yes, you are all right. So everybody is there, and you have not slept off because since I am speaking slowly, you might be getting sleepy, and it's already late for some people. Yeah, MapReduce will store the data on HDFS and will sort and put it. All right. Okay. So basically, HDFS is first thing that we need to understand. So in both the forms, in HDFS as well as MapReduce, we have these master slaves. And let's just ignore the upper part and just focus on the HDFS part first. So HDFS cluster, when we think about it, it has two kinds of nodes. First node, which is admin node, is singular. There is no other admin node. And it is just keeping the metadata. Okay. So, and there are other kind of nodes, which is data node, which keeps actual data and do the read writes for you. Okay. So whenever they will be providing reads and writes. You will be reading the data from them and writing the data to them. Okay. So whenever you store a file, is split it into small chunks. Okay. So and the core of Hadoop, again, I'm describing to you that there is HDFS and there is MapReduce. Now HDFS basically is called is the processing is the storage is across the nodes, and processing is it in MapReduce. In MapReduce, it splits the task across processors and nodes, and it sends the code to the data instead of sending data to the code. And it is self-healing, high bandwidth. We'll talk about what does these mean in detail. And now let's talk about HDFS. Okay, HDFS basically has two kinds of node. One is name node, other is data nodes. So these are data nodes. So we have got 5 data nodes, one name node. So name node is going to store the metadata, while the data nodes are going to actually store the actual data. So say you took a movie and you asked HDFS client to store the data. Okay, so it will name node in return. So HDFS client will ask the name node that, hey, I want to store this particular movie. So name node in return will say that you store the first 64 MB in the node number 1. The IP address of that node is this. And then you go to store from 64 MB to next 64 MB data to on the node number 2, and the rest of the data you can store in node number 3, and so on. Okay, and also the copies of each data, these details are given by name node, saying you go to these nodes, store this much of data from 0 to 64. You should store in first 3 nodes, then the second chunk you store on these nodes, and so on. Okay, now your client when we say is basically that library, that command line library which is helping you out in talking to HDFS, will go to each node, will connect to the each node as mentioned by name node, and start talking to that particular data node. Okay, that data node as mentioned by name node, when you went to the name node, when your client went to the name node said that, hey, can you go to these nodes and store this data from your file. I'm not going to do anything for you. You have to do it yourself. All I'm doing is giving you a list of nodes where you have to store the data. Okay, that is the response of name node. Name node does not want to become the bottleneck. Okay, he just is a facilitator. He just keeps the metadata details, and that's the full stop. The name node does not want to do any reads, any writes, any splitting magic, or any other things. All it does is maintains the metadata, meaning which piece is located where. Okay, which piece is located where. Right now, your client will connect to each of these data nodes and then store those pieces at various places. Now, those each data nodes will basically take your piece and store in the hard disk of that computer. Okay, there'll be a dedicated folder which is configured by default whenever you install a data node daemon or data node server onto a machine. So basically, there is a name node server, there is a data node server, there is a MapReduce. All of these have got one processes running in the backend to receive all of these requests. Okay, so your client is talking to each data node and asking it to store the data, and data node is taking your call, taking your request, storing the data, giving confirmation to you, you as your client. Now, client, once it finishes writing to all the data nodes, goes back to the name node saying that I am done with writing the data. And that's the point where name node says that, okay, fine, I have made a note of it. Now you can go back home. Your job is successfully done. Okay. So this is how the HDFS work. All right. Now let me answer your questions. So where exactly data is kept on data node by HDFS folder? Right. So basically each data node has dedicated folder where each file is stored. And there is no such thing like a format like plain text XML. It's basically chunks. Whatever your file was there, it will take that file, those bytes, and store it in a file. That's all. Okay. Whatever is your format. unless and until you are specifying that you want to zip it. Then in case that your client will try to zip and put it there. So client is running on the machine who is trying to copy the data. Okay. So there could be a machine in your network which does not have any data node running, but has the client. Okay. So client is an independent. So client is basically a library which can be installed on a machine even if it's not a part of cluster. And client knows about the machine which is data node, which is name node, and therefore it is able to figure out. So each client, when you install, you can configure that this is my name node. This is where my all the requests to store and save need to go to the name node. Name node in turn give you the domains or domain name of all the uh, domain name of all the data nodes, and then you can connect to those. Okay. So was I able to answer Giriraj and Akhilesh? No. Okay. Okay. So can take okay, let me take a real life example. Say you have 1 terabyte data lying in your personal computer, okay, now on your at your home, and you are building a cluster now which is in say somewhere in Bombay. Okay. So you installed Hadoop over there, which is running say few data nodes. Now, the moment you want to copy this data, which is locally lying on your computer at home in Bangalore, you want to copy this data to your cluster in Bombay. So what you do is you install the Hadoop client over here also in the local computer at home in Bangalore. And in this Hadoop client, you can configure that this is where my name node is. And then when you ask this Hadoop client that, hey, I want to store the data, it will be talking to the servers, the name node, which is lying there in your cluster in Bombay, all right, or Mumbai. Right? So it will take the file, talk to them, and then the name node will say, go to these data nodes and store the files over there, and that's how it happens. All right. So how many data nodes can be configured? The ideal way is to have almost all the nodes except for name node uh, to be operating except for name node and one more node which we dedicate to Uzi. So say you have 10 nodes. The general strategy is all eight of the 10 nodes are dedicated to data nodes. So this service is running as data node on all these 8 nodes. On the first node, you do not install data node, and then you dedicate it for the name node. While one other nodes, which that let's say 10th node, is dedicated to Uzi. Okay. So because the one which is going to run Uzi should not have any other headaches, right? Any other processing running on that machine, because Uzi will also do a lot of processing locally as well as on the cluster. So the general strategy is to have one launcher box, one name node. Launcher box is one from where everything is being launched. And generally the Uzi is the one which is launching this stuff. So we have got one launcher box, one running a name node, and rest are data node. So that is the general strategy I have actually followed in past. Okay. So was I able to answer Akhilesh? Any limit can we set on data node? Ideally, no. You should not be setting any limit on data node. Okay, the more the better, because that is because all of your node are going to provide you a disk space and storage, and the more redundancy you have is better. Even if you are able, even if in the network you have 100 MB available on a node, it can become a backup of somebody. Right? Therefore, the more the better. The general thumb rule is the more the better in case of data node, and we don't set any limits on that. And Anima's question is that where is the client installed? So client is actually installed on all the nodes. Okay, so when we say Hadoop or when we say HDFS, so there are two parts. One is client, other is the daemon, the servers. Okay, so mm, client is installed by default on all the nodes. It is the server which you need to set up and tell that I want to run data node on this one and name node on this one, and then configure accordingly. Okay, was I able to answer Anima? Anima? Okay, so right, replication is that here, if you see, when the client has finished writing to both the here, one data node here, other data node here, and the replication is happening between these two nodes. Okay, so the moment one piece goes down, the other piece is available, right? So name node and these data nodes keep on replicating the data for you. Okay. That's a direct communication between data node to data node. Data doesn't come back to the client and then go to the data node. And most of the replication is done between the data nodes itself. So where is the server node installed? Okay, I think I confused you a bit. So whenever we say data node is nothing but a server or a service. You can think of it as a service. Okay. It's a daemon. We call it daemon in Unix terminology. Every service is called a daemon. Now, okay. So basically, every form, whenever you think about MapReduce has a client, okay, as well as a server, right? Server receives your request and does the job. We'll talk about it again. All right. So this is the general architecture of HDFS. Name node maintains lot of metadata and it maintains it in the RAM. In case in case the RAM is very small, it will increase the chunk size from 64 MB to 128 MB because that will reduce the metadata size, and it will keep on increasing based on the RAM we have available. All right. And the default chunk size with respect to HDFS is 64 MB, and Cloudera HDFS or Cloudera Hadoop, which they have taken a little bit of deviation. Their chunk size, default chunk size is 128 MB. Okay. Now, so this is what goes on when we try to write a file. So HDFS client client is your command utility which Hadoop has provided, or the driver which Hadoop has provided you by the way of various jar file or other formats. So client can be a command line or CLI, or it can be a Java library. So what it client does is whenever you ask that I want to store this data, it will first go to the name node. Okay. DFS, when we say DFS, the DFS will talk to the name node, and the name node is going to give you a response back. Then hey, go to these nodes and store this data, and then and then it will go to that particular data. It will go to that but those nodes and store the data. Similarly, when you try to read the file, this basically requests name node to give you the block locations. Where is each chunk stored? Chunk, block, piece, all of these are being used interchangeably by various people. So here it asks for block locations, means it's asking for chunk locations, and it tells you that first chunk is installed on this machine, second chunk is installed on this machine, third chunk is installed on this machine. Go there and get it. Okay, right. So, this is how it happens. Now, this distributed file system or the whole client library, you can think of they will merge all these chunks together and give you a single file. Or in case you want your library wants to just access a particular chunk, the library or the client, they provide you facility to just get one chunk. Say if for example you're building YouTube kind of service, in which case you are allowing people to drag the cursor to particular location. In those cases, you can ask the library to give you only a particular chunk. And in that case, only that particular data node on which that chunk or block was stored will get loaded, and rest will not be impacted at all. Okay, now Nagendra's question is, what if name node fails? So there are two ways, two answers to it. First is there is a secondary name node which keeps the copy of metadata with it, but most of this metadata is there, but you will have to do a little bit of manual intervention to bring it to live. Okay, if your name node goes down, it takes a little bit of building up time, right? It is not an automatic failover, but there is a failover node available nowadays. Hortonworks and couple of more people have done a lot of work in which name node is kept as a name node always has a mirror, and the moment name node goes down, you have a mirror taking the place of name node. Okay, was I able to answer, Nagendra? So Amit, was I able to answer your question, Amit Sharma? Great. Great. Now let me move on. So name node metadata looks like this. Say I want to store a file. The part 0 is stored on first and third node. Part 1 is stored on second and fourth and fifth node, and so on. This is how it goes. And R colon 2 means this is what the replica factor I have requested, and therefore there are only two nodes having the part 0. All right, this is just an example. Now, second part. So, hope before I move on to further to the further to the MapReduce, sh- is everything clear to you guys? Any questions with respect to the HDFS right now? Feel free to ask if you have any questions. Okay, great. Now moving on, moving on. Feel free to interrupt and ask a question at any moment of time. Okay, okay. So basically in HDFS, all I explained was that we took this. Okay, so here, so all I wanted to describe is there is a client which goes to a name node gives it that, hey, it you go to these data nodes and you write this. Okay, why name node does it? So that he doesn't have to read write on behalf of yours. Okay, and basically it the client splits this files into data small chunks and puts it onto various data nodes, and where the data is also replicated. Okay, so client also stores the data to the data nodes, or data nodes copy it between amongst themselves. So can you show the slides for little more, which was talking about the metadata? So this is one example of metadata. Metadata is name of the file, okay, then number of replicas, and this one. Now you can see that. So metadata is basically list of files, list of blocks of each file, list of the data node for each block, and file attributes. Right, right. So admin node, yes, there is a huge chance of admin node failure. Therefore, there are two mechanisms. One is secondary node, other is mirror node, which Hottenworks guys are working has done it. Okay. So there are huge chance of name node or admin node failing. Admin node and name node are allies to each other. It's the same thing. Okay. All right. So it keeps everything. The name node or admin node keeps everything into the memory and does that. All right. There's another thing which it keeps onto the disk is the various transaction log. Okay, and nothing else. Now, the other aspect is your job tracker, the MapReduce engine. MapReduce engine is identical to your architecture of HDFS. There is a node called job tracker whose job is to take your request, okay, and do the manager's job. Then job tracker basically figures out that which task tracker can do the job. So task tracker actually executes the task. Job tracker doesn't do anything other than doing the bookkeeping for you. Okay. Now, so whenever you want to execute a particular logic, you ask job tracker to do the job. Now, job tracker will also ask you which are the files you are trying to churn, right? And in case you're giving a file that this is the file I want to churn and this lies on the HDFS, that file should lie on the HDFS. Now, job tracker will ask the name node, "Hey, can you tell me that where is this file located? Where are these pieces located, right?" And finds out the task trackers closer to those data nodes containing the pieces of the file, right? So, so say you have a very big file, okay, stored on say 10 nodes. The ideal scenario for job tracker is to send the execution or processing logic to these nodes which are containing this data, because that will be extremely fast. No network overhead at all, right? So, and basically, basically job tracker asks the admin node or name node for the list of the nodes which are containing that particular file. Then it examines which of the task trackers are closer to those nodes containing that particular chunks. Okay, because and then only ask those task trackers, right? So basically, job tracker's job is to do the work, to get your work done via task trackers. Now, in your network, there could be say 10,000 task trackers. Which which task trackers are best for you will be decided by job tracker. Okay, and one of the decision parameters is which one is closer to the file which you are trying to process. Okay, or closer to the chunks of the file which you're trying to process. Say there is a 1 terabyte file, you want to do a sorting on it, right? So you wrote a logic how to what is the key, or what. So you wrote your function in the form of map reduce and gave it to the job tracker. Execute this map function on on the cluster. Okay, now it will find out where all the file you're trying to sort, where all is it existing, and then it will find out which are the task tracker, the guys who are ready to execute your job closest to the data node. In case it is not available on the same machine, it will try to find out the node which is on the same network, which are connected to the same hub. Then it will try to find out in the same data center or same rack, and so on. Okay, so basically it has a very huge optimization for the rack awareness, or there's one very good term for I mean basically the rack awareness. So I'm sorry. So the job tracker's job is to basically execute your job and minimize the data transfer as much as possible. Okay. Now in the in between, right? So you can look at this one. So job tracker is like a butler in a hotel who takes your orders and then asks the cook to do the job. Okay, your order can have multiple things, or your order, when you ask for some dish, it might be prepared by multiple cooks at the same time, and those cooks are what we call it task trackers, who do the actual job, right? And which trackers are going to work on your order is decided by the nearness to the file which you're trying to process. Okay, it's actually pretty simple. Now there is one more aspect of the job tracker. So this is what it is doing. So whenever you have to process the data, first you copy the data which is onto the Hadoop distributed file system. Then you ask the job tracker, you ask the job tracker to, you submit the job to the job tracker. Job tracker will then create the splits. Okay, splits as in splits as in say you are trying to it's already splitted, right, internally. So similarly on the each split your jobs are going to get executed. All right, so you, as a client, you ask job tracker to do some job. It initializes a job. Now it has also listed down all the guys who are doing working for you. Who are the task trackers doing the work for you. It has made a list of it, and it is like a register, or you can think of it as a queue, and also notes down at what time did it give the order to each task tracker. If the task tracker does not respond within within a guarantee, then it abandons that particular task tracker and sends the work to the another task tracker which is closer to the data. It can be on the same network and so on. So this way it is resilient. Resilient meaning in case one task tracker goes down, it is sending the same work to another task tracker immediately. And it does it for some time. Excellent. Mega has asked the question at very quick time. Right. So yes, Sriram, I'm going to take maybe 15 more minutes because I had taken a 15 minutes break. So I'm going to take maybe 15 to 20 minutes more. Okay, Sriram? Right. So this is what a job tracker does. All right. Maybe I'll take only like 10 to 15 minutes. No worries. Okay. So this is what is going on inside you, inside this whole job tracker, task tracker. Okay. And it's the same thing written again. And also a job tracker tries to ping a particular task tracker and see how is the response and accordingly takes a step. Okay. Now the next thing so this was more or less what a job tracker does. Job tracker takes your task, divides it amongst the task trackers, and then basically keeps a exactly like a you know bookkeeper, or exactly like a supervisor of a workshop. It keeps a record of who is doing what, and is anybody finished the job or not. If anybody has not stopped responding, and all those aspects. And in case it needs to just abandon one particular node and move the same processing to another, it will do that. Now, this is what the job tracker task tracker does. So we just describe how does the distributed computing work in case of MapReduce framework. Okay, right? So this is what the job tracker task tracker does. So this logic can be in any format. Okay, so it first the processing got distributed, multiple computers are doing your job. Second, the data overhead got reduced. Third, the resilience happened, meaning in case one task tracker dies, there is another one which is doing the job. So there are three benefits of having this kind of a framework. I could also build my own, but would take me a lot of time to build these things. Okay, and therefore it makes a lot of sense to use MapReduce engine. All right, and this distribution of task and doing all of this is now taken up by a component called yarn. This has started coming under yarn after a recent rewritten after Hadoop has been a bit rewritten. Okay, now, and so that other kind of processing are possible. Earlier only MapReduce was possible using distributed computing. Now there are other kinds of processing is possible. Now let's talk about what does it mean by distributed MapReduce. Okay, we talked about distributing your logic, but what actually happens inside a MapReduce? Okay, so the MapReduce so MapReduce basically is a composition of two functions. One is map, other is reduce. Okay, and these are the two functions written by you based on your requirements. Okay, now say for example the input to the map is one portion of your file, and the duty of map function of yours is to give out key value pairs. So you can think of it as like it will MapReduce framework will take your file line by line, give it to your map function, where you will code it such that your map function will give out some key and will give out some value. Okay, and and all of those key values will be sorted by MapReduce framework for you. And once it has finished ordering it, then it will pass it to the reduce functions. So the way it happens is, say your file has three portions: split 0, split 1, split 2. These are the three chunks, or uh, uh, three three sections. Okay, now now your map function, whatever you write, it can be anything, whatever you wish to do. All it has to do is give out key and value pairs. Okay, so whatever output the map function gives, it will be combined and merged together and will be sorted by Hadoop framework. And after it has done that, it will go through the phase called merge phase, where all the output of key value pair is merged together, and then the reduce function will be executed on all the values of a key. Okay, so say there are 100 keys and each key is having some 15 values. So reduce function will be called 100 times on each key, and there will be 15 values in the array which is being passed to the reduce function. Okay, the job of a reduce is to do some magic on the values. Okay, the other way to look at MapReduce framework is like a group by clause. If you guys are from SQL background, you say select star from my table where something, and then you say group group by this column, right? Select ID comma average salary from employee's salary, group by ID, and then and that's all, right? So this way you can get the average salary of each ID. Now, what does a group by do? Group by has two portions. One is you are saying that, hey, I want to group by on this particular column, right? That is the identification of marking a column number, a name. That this is the column on which I want to group my data, right? Now, there is another aspects to it. What is your aggregation function? Average, as I said in this query, is my aggregation function, right? Select ID average salary, and that is my aggregation function. So similar to group by clause, MapReduce is similar to group by clause in that sense. Map function, map function identifies what is your key, right? What is your key on which you want to group your data, and reduce function tells that how to group that data. Okay, so we'll go into a very detailed of MapReduce, how to convert every logic into MapReduce. In case you did not understand MapReduce right now, do not panic. It is because I have not given a good examples right now. We will be going into more and more details of MapReduce, and make sure that you understand how to convert any problem into MapReduce. Even if you do not know how to program in any particular language, but you know the basics of programming well enough, then you should be able to handle most of the MapReduce jobs very well. Okay, this is my personal experience, and why I want to emphasize on MapReduce while most of the other people do not do that, because Piglatin, Hive, and all other aspects, all other components, they under the hood use MapReduce to do all of their computation, and therefore every time you will be using those, they will under the hood convert MapReduce. If you don't get a feeling of what exactly they're doing, you will never be able to optimize your pig latin script or your hive script or your any other computation, data computation. Okay, so that is why, I mean, when I teach joins in pig latin, you will question me that why can't I join the two data set the way I used to join using my standard SQL table. And until and unless you have a clarity on how MapReduce function work, you will have this kind of questions. Okay, and therefore I want to emphasize again that that MapReduce understanding of MapReduce is very important. Okay, I'm sorry, I got all right. So any questions at this point? So map is basically converting your data into key value pairs, and then MapReduce framework will order your data, all of these data is split it out by your map function into a into an ordered list, and then reduce will basically combine the data together. All right. Are you guys there? Any questions at this point? Okay. So Ananta is there. Is anybody else there? Okay. Great, great. So everybody is there. Excellent. Excellent. So we will be for next two sessions, we will go into the details of MapReduce, and then we'll go with Hive, Pig, uh, Zookeeper, and HBase, and then we'll talk about Apache Spark, which we have not talked yet. So we'll dedicate half of the session to Apache Spark, and then we'll take up Mahout in one of the sessions, and then Scoop, Flume, and everything in the whole ecosystem of Hadoop we'll talk about. So Giriraj is saying that when you are merging the data, you lost the advantage of splitting. You are right, Giriraj, but there is no other way of doing the merging. Okay. Therefore, there are a couple of optimizations done by Google and Hadoop guys. First is only transmit the data between the various nodes which is actually required to be transmitted. Right? So one of these nodes, instead of there is fourth node doing the merging, you pick up one of the existing node which does the merging, which means two-third there will be two-third of the data transmit. Second kind of optimization which is there is that after the map has finished, you can run couple of functions which does some of the job on that particular node itself to reduce the data size. Okay. So there is a little bit of optimizations required. So the next session is tomorrow. Okay. The next session is tomorrow at the same time. All right. That's Aklesh's question. And Girira, are we merging the whole data or merging it in? Are we merging the whole data or merging in the EPI, ECECS, and okay, merging in the pieces, and this process is done iteratively to complete data. Okay, so we'll be basically here once the map has operated on each split, there could be hundreds of such nodes on which the map has run. Okay, if you have got 6.4 GB size, then there will be 100 nodes, right? And once you run on 100 nodes, maybe 100 nodes, maybe less, okay, based on number of nodes you have. And all of this has to be copied. Okay. And this merging, when you talk about reduce, so reduce will happen only once. For keys, a value, say there is a key and there is a say 100 values for a key having the same key, right? So the reduce will be executed only once. Okay. While there are other functions which are executed on each node, they will be executed iteratively, right? On each two pieces converting into one. That's another one. Okay. We'll talk about it in details, but that's a very good point you have brought in. Okay. So in case of reduce applies on all the values of a key in once, while while when we are trying to summarize the values here on each node, then it's not guaranteed that how many values will be applied together. Okay. So there is that's where what you are coming, what you have come up, that kind of optimization is done on each node. All right. So that's pretty much from my side. And those candidates who have taken up, because there are some candidates who have already taken up the full class. Okay, they will be attending the classes from tomorrow. Okay, the second class will be tomorrow. This was their first class. So you can go to first log in into LMS. There's an installation document. You go to that installation document. Also explore the admin console. Okay, there is a login password required for the admin console. You that and those all the login password details are mentioned in the installation document given in LMS. And admin console one is Ambari. Okay, Ambari basically gives the health of all the nodes. And using Ambari, basically it is very easy to manage the cluster and very easy to install the cluster. Okay, I mean the I mean making a particular node a data node and removing a particular node, removing data node from a particular node is very quick using Ambari. Okay, so those kind of things are basically, it shows you, Ambari shows you the complete health of your system, while Hue makes you interact with all of these components. Using Hue, you can execute you can browse through the whole HDFS like a file system, and then copy paste files, download files, upload files onto that one. Okay, and under Hue you can execute the Hive queries, Piglatin queries, and Oozie workflow. All of it could be done through the browser. You don't have to use the command prompt. All right, now finish the quiz. uh, Finish the quiz which is mentioned in my courses, and the and it has got around 50 questions. Most of it will be based on the today's session, as well as some more questions, general questions. And as Give mentioned there, set up the Hadoop environment on the virtual machine as well, although it's not required, but that gives you a sense of having ownership, having your own virtual machine as well, but that's not required. Now, explore the whole cluster, and in case you are trying creating a file, create your name and then you create a file. All right. Right now, only the people who are doing projects, they are given a separate login, while all the students who are in this particular session will be sharing the same login so that they can evaluate each other's work as well. Okay. So Amit Sharma's question is, what is difference between Microsoft's Big Data HD Insight and Hadoop? I have to evaluate Microsoft's Big Data HD Insight and then I can compare, right? But most of the people have actually taken up Hadoop and try to build upon it. Okay, so that's it pretty much. In case you have any doubts, any questions, drop me an email. Drop me an email at hadoop@knowbigdata.com so that I can answer your question and I have the context that you are from Hadoop session. And in case you get stuck, you just immediately drop an email. Okay, do not hesitate. All right. And the other way is that SSH. Try to set up a passwordless SSH with our servers so that you don't have to keep on logging in, logging out, because there are around 12 nodes for you guys. So it makes a lot of sense to have the passwordless access. Okay. Okay. So the basically second class is tomorrow, 14th September, 8:30 p.m. And basically the charges are 15,995 including all the taxes. Okay. And so that's pretty much it. Okay. So, okay, that that answers your question, Kavita. And somebody else also asked me this question. Okay, for those who want to, take up the course, let me know immediately, because I will, because tomorrow is the second class. Okay, tomorrow is the second class. So if you, whatever you questions you have, just give me a call, and then let's, discuss it and take it further. Yeah, 15995 for all the classes put together. Okay, okay, great. Thank you, Akhilesh. And let's catch up tomorrow. In case you have any doubts, feel free to drop by. Okay. Thank you very much, guys. And yeah, even if you do not want to go for the full course, do stay in touch. All right, because there are, I mean, there are various ways we can work together, and okay. So even if you're not taking up the course, do not feel bad about it. Just stay in touch. Okay. Thank you, guys. Thank you, Amit. Thank you, Karthik. Thank you, Kavita. Thank you, Anima. Thank you, Akshay, Ananta, and yeah. Okay. Thank you, Nagendra. Nagendra, do you have any question? Okay. Thank you, Giriraj. I'm happy that you liked the session, and thank you, Nagendra. I'm happy that you liked the session very much, and I have a little bit of throat problem. That's why I'm not talking too loudly and too aggressively. So, yeah. So feel free to drop me an email. Thank you, Anima, that you liked the session. Okay. Okay. So Akshay is saying that this might change my career. Interesting. So I would love to discuss how does it impact you. And okay. So do drop me an email at Sandeep at KnowBigData in case you have any questions, doubts, even if you are not going ahead with the full session, or do stay in touch, right? And uh, when you are working, I mean, the way it happens is when you are attending our sessions, you are generally like working with us, okay? And we make sure that you really get a good exposure as well as you get a great connection to the industry in the big data domain. Okay. Thank you, Ravi Teja. Okay. I'm happy that you liked it, the session. Okay. Thank you, guys. You were very good, very good interactive uh, uh, questions. I liked your the set of questions you asked. Yes, Akshay. Yes, go ahead. Okay. So Kavita is saying that I never imagined webinar would be so good. Actually, before I started webinar, I never realized that it is actually possible to explain concepts using over webinar, and that also had changed my perspective. Nowadays, whenever if somebody is asking to explain things, I generally say that let's do it over Google Hangout and have these kind of things ready. Okay. And yeah, I too got this. So Akshay's question is, what inspired you to get into data and things after chemical engineering? So it did not happen with the chemical engineering. Basically from my second year in college, I have been doing a lot of programming, lot of coding for the college. I was the chief programmer for IIT Roorkee, and there's like one in out of the whole college. And so I actually like programming from the day I started interacting with computers, and that happened in my second year. So since then, since then, since then, I have actually talking to, continued with programming, and it has been very rewarding for me. I was not a very chemistry kind of person. I couldn't do any chemistry things earlier. Yeah, Disha was great. Disha, out of 800 people in college, they hired, I mean, I was the only one got selected from college, and they were the highest paying company at that point of time, and the company who was the highest in the technology at that point of time. Because, I mean, Google was not there. Microsoft was paying far less than Disha at that time, as well as Microsoft did not have that great reputation as compared to the to Dish at that time. Okay, Dish comes to the college. Yeah, but Dish at that time, when I was at Dish, we were like 80 people. Now they are like 800 people, and it is yeah. Now getting selected in Dish is far easier. Okay, they have because they had to expand, right? So I'll be sending you an email, Mega. Okay. And the only thing is I'll have to upload the video, and that might take couple of hours. So I'll be sending you the uh, f- uh, video as well as the PPT by tomorrow morning. Okay. What is good to guys working on SQL go for? Okay. Okay. So see, Microsoft BI, you should anyway go for it. Okay, they are not if and else. Okay, so if you're working, so Amit's question is, what is good to the guys working on SQL Server database? Should they go for Microsoft BI or Hadoop or Microsoft HD Insight? Okay, so first let me just break this question into two portions. MSBI or Hadoop. So MSBI is, say, must-have thing. Okay. So whenever you are churning a lot of data, once you have finished bringing the data from a big data to a smaller data, meaning that the results, say statistics of of all the cities in India, say that will be smaller data. Say you want to compute the GDP per city, given the GDP of the whole country in each individual, right? Now, the statistics are generally prepared on a smaller data, and the same case is Microsoft BI. So you'll be using MSBI in conjunction with things like Hadoop. Okay, so you cannot say this or that, right? Now, second question is Hadoop or Microsoft HD Insight. Now, on that, my take is that Microsoft HD Insight is most likely be inspired by Hadoop themselves, and therefore it will be it will make a lot of sense to learn Hadoop because that same knowledge will apply over there. Okay, 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 guys. I'll have to take a break now. Good night. And Akshay, I will answer your question. And can you just drop it over a email, right? Because the okay, I'll just take a note of this one. All right. So his question is, how is Hadoop different from Teradata? I'll take it up over email. And good night, guys. And I'll have to take a break now. Okay. I am, yeah. Good night, guys, and have a great day tomorrow. And feel free to come connect if you want to. If you want to, you know, have any question. Okay. Bye bye. Good night. Good night, Kavita. Thank you for the good questions and good set of being a good set of audience.